This is gonna be fun. Configuring a service provider network. Man, you're wondering, why did you start it off? I don't know. It just happens sometimes. Before I dive right into the scenario that I've built, which I'm so excited. It's great because so many of you know that I now gear a lot of my series around GNS3 labs, and I instead of just demonstrating stuff nowadays, I used to, and that used to be how I did everything. What I do is I demonstrate stuff based on a lab scenario, and I create requirements and all that kind of stuff, which takes first off, I will say it takes me probably 3 times as long now to get ready for this. But I think the result is awesome because not only do you get to see me walk through what I would call a BGP lab scenario, which is pretty cool, but then you get the opportunity to do it yourself if you tinker with GNS3. I provide all the topology files for you to practice and all that. And I would say an additional benefit is it just psychs me out creating those lab scenarios. By the time it's done, like I said, it takes so much time. Like about halfway through writing those things, I'm like, oh, I'm ready to record. And I'm like, no, oh, wait, I want to throw this in there. No, okay, no, I'm gonna throw this. And so by the time I hit like the final bullet point of verification, I'm like, let's go, let's start recording it and doing it and working through it because it's gonna be cool. So that number one feeds my excitement. Number two, I'm gonna be adding just so much more to this from a new perspective. Many of you know I do independent Cisco consulting. I have for well, it's going on 12 years now, where I just, and when I say independent, I mean it's just me. I go out to a customer premise and, hey, we've got a loop going on, we've got, whatever. I just, I do whatever, usually break fix kind of stuff, or a new rollout of, say a 6500 switch. It just, it just keeps me grounded in reality. Well, a couple of years ago, I started a company called Easy IT, simplyeasyit.com. And what it is, it started as just managed service provider system, and meaning I kind of roll out a managed IT system to small and mid-sized customers. Well, as the years have gone on, we moved into a data center. We started doing some of the quote-unquote cloud services, which really mean nothing. It just means you're running your stuff off site. So we started dabbling in all of that, and then somehow in the last probably about 6 months or so, we started exploring the idea of becoming a service provider ourselves, which is now becoming a reality. So oh man, I'm so excited to kind of start bridging some of the stuff. Like, it's not so much that I've now had a radical new shift in. Well, I kind of have. It's more of like my mind is now so geared to where I am the service provider and I'm giving all these clients a service. So I'm going to blend a lot of that in here. So, two major topics. You're like, is there more than this slide? Not really, but there's going to be a lot more discussion. First off, I want to give you a GNS3 tip because I've run into this probably 3 times now, and every time I don't document it, so I have to relearn it. I'm like, I'm just going to show it to you. GNS3, when you throw a bunch of routers at it, it just blows up. I mean, it reaches a point to where it just can't handle them all in a single I'll call whatever, a single thing. So you have to kind of divide it up. So I want to show you how to do that, and also just talking about it will solidify it in my head. So the next time I run into it, I don't have to go googling around of why is my GNS3 blowing up. Second thing then is I want to walk through that transit autonomous system lab I created. Which is going to be cool. It's going to go beyond just this nugget, but that's okay. It'll be a good experience. Okay, so before I dive right in here, let me give you that tip on GNS3. This is our topology for this scenario that we're going to do. And what I find with GNS3 is it blows up. Sometimes around 5, 6, sometimes 7. It's kind of inconsistent because I don't really know what causes it. But what you'll see is you'll start your routers and you'll start seeing them load. And somewhere around 6, it's like, boom, I've lost connection with Dynamips. Everything's on fire. You can't do anything. All that kind of stuff, and you're like, what's going on? So here's the scoop. Here's what you need to do. Let's see, where's my GNS3? In GNS3, here we go. Here's my topology. If you go to the Edit menu and go to the iOS and iOS image and hypervisors. Is this where I need to be? Yes. You can see right here that I actually have external hypervisors. These are essentially what I would call interrupts. And first off, I'm not a GNS expert. This is just from, I would call it street knowledge, if you will, just from tinkering around. These are essentially interrupts to the processor. Some of you might just have one. Some of you have multiple. My machine. Let me see what I'm at. I've got what do I have? Two dual quad core. It's i7 Intel i7 chip. So just by default, I think when GNS3 starts, depending on where it's installed, it will just have one. You need to add in multiple hypervisors, which is essentially a processor interrupt, because if everything is installed on one, essentially all the routers are coming in and they're like, hey, we want processor, and it all comes through one, and that, for whatever reason, that pipe blows up and causes Dynamips to crash. So what you need to do is add multiple hypervisors here. All you need to modify, and by the way, it does this for you. You just come in here and just click the save button a few times. It automatically increments the host port number and the base UDP port number that it's using. It just does it. You just kind of add them in there by clicking save. So you add a couple of hypervisors. Now, and a lot of times I've found that this is the default. It'll have a few hypervisors by default. But when you create your topology, like you just start dragging and dropping the routers on there, it only adds them to one hypervisor. So you've got one hypervisor kind of handling all these routers, going choking. So what you need to do is save your topology, kind of drop out of GNS3, and go edit the topology file. Now I know many of you have done this to change iOSs, things like that. Now, if you right click on this, like for instance, if I hit edit with Notepad++, I actually have it right over here. This is the file that shows up, and by default, you'll see right at the top, that shows this is the hypervisor these are assigned to. And then here's my image that I'm using for this 3745 router that that's the model I'm using. And then here's the configuration for every single router. Now, by the way, behind the scenes, this is the Dynamips configuration. This is what Dynamips needs to make it work. And if we didn't have GNS3, we would still be able to do this. We just wouldn't have the pretty picture, and we'd have to go in and edit a bunch of text files, which lame. You don't want to do that. So GNS3 does this all for you. So what I did was I went in here and said, okay, well let's do this. Edit this text file, and somewhere around what did I do? Let's see, four. Well, hang on, 1, 2, 3, 4 routers. So 4 routers into it, I said, okay, draw the line, and I squeezed this in. And Jeremy, how'd you know to do that? Copy and paste, my friend. Just went up to the top and said, okay, well, looks like this is what is assigning it to the hypervisor, so let's just copy that and then find my little router break and squeeze it in. Just kind of squeezed in the hypervisor that it's assigned to, and I incremented that by 1 to what I saw in the external hypervisor. And then I started throwing these other routers under there. And I think I have, what is this? 1, 2, 3, 4. 4 different. It's an ether switch, but we'll say 3 or 4 different routers underneath this guy. And if I needed to add more, I'd just go ahead and squeeze that in again. So that's what I did to make this work. So if Dynamips is crashing on you, that might be something that you want to look at. So with that in mind, let's dive into the scenario. So I'm gonna now. I know we're early on in this series, meaning I think this is the second GNS3 topology I've done here, I think. But sometimes I go through these things, I create the scenarios, and then I fully test everything. Like, let's try it out. The PDF is locked, read only. This is good. Sometimes I feel a little more, spontaneous, and I write it up, and I'm like, I could run through and test everything, but I'm just ready to go. So you may see, for instance, as I'm recording, all of a sudden this changed from like 3 to 9 or something, because I'm like, okay, that blows up GNS3, or that's just not possible. Sometimes I'm creating this off the top of my head, and I'm like, I just created an unsolvable scenario. I've done that a couple times. So just work with me here as we work through this, and we'll see how it rolls out. So here's the scenario. You see the topology. We've got, congratulations, you have been awarded a $2.3 million contract to build the Nugget Labs Fast ISP data center. It's funny, when I created this, I thought, okay, $2.3 million dollar contract to create a fast ISP, and I was like, that's really expensive to kind of start an ISP. And I was like, oh, data center. And then I was like, that's really not enough to build a data center, but nonetheless, that's where we're at. So we've got our little data center we're building here. This state-of-the-art data center will provide internet access to customers, both internal and external to the data center, connected through various layer 1 providers. So let me stop right there, because I added this since I became part of the, I guess I could call it, service provider world myself with the company that I've been creating. And let me just scroll back up. One of the things that you'll find. Let me just take it over to a whiteboard. It'll be a lot easier to explain that way. Let me talk about a data center. I mean, data centers are kind of whimsical, magical. Here in Arizona, we have a ton of them because the biggest natural disaster we have in Arizona is a tumbleweed blowing by, and it's really hot outside. You know, we just don't have earthquakes and tsunamis and everything else that happens. So this makes us fertile ground for data centers. I've been in a lot of them. So when you think of data centers, there's like I was saying, this almost mystique about them, but really, there's not too much to them if you really break them down. I mean, they're big, they're glossy, they look great, they got crazy cool security and retinal scans and things like that. But here it is. Here's your. Let me draw it bigger. This is our purple data center. You ever read the book Harold and His Purple Crayon? Having flashbacks to my childhood here. Here's our data center. We've got in that data center, you know, you've got the front doors with your man traps and your retinal scans, all that kind of stuff where people come in, and you have all this floor space with just racks and racks and racks of customer equipment. Well, in that data center, out back you've got the generators. Here's generator 1, generator 2. So if the power goes out, that data center can be self-sufficient for 5 years or whatever, whatever scenario you want to throw at it. But inside of there, you essentially have all of your customers. Let me just put a dotted line. All of your customer equipment, and then you have the service providers who come buy space in that data center, meaning all these different service providers, run fiber optic cable into that data center, all in different conduits, all through different spots, hopefully, depending on the data center that you're in. So let me just, I'm in Arizona, so I'll throw a few of them out here. We've got like Cox Communications, we've got like CenturyLink, previously known as Quest. We've got like XO Communications, Integra. There's just, a ton of service providers. So they all run their fiber optic lines into there, and then they wait for you to come and pay them. Essentially, you as the client, and it depends on which way you go. For instance, this data center, a lot of times will offer what they call a blended solution. So when you sign up for a rack of space here, you say, okay, I want to put my servers offsite. I want to go into a data center. What they'll do is they'll say, well, we can provide, for, I don't know, $1,000 a month. I'm just throwing a number out there. We'll say 50 megabit per second blended solution. So what the data center does is they have their equipment. We'll just throw some routers or layer 3 switches or whatever, that they receive the fiber from all of these different guys, these different carriers coming in there, and they blended them all together, meaning they establish BGP relationships with all these guys through their equipment, and then they deliver to you, we'll say, a fiber optic cable or a copper cable that they police down to 50 megabits per second, where if that's Integra, if XO, if CenturyLink, if Cox, if any one of those goes down, that's cool because their router detects it and says, okay, well, we'll route you out the other carriers. This is making sense, right? So you, as the customer, get your own servers that are now handling through multiple carriers. So no one carrier failing will cause you to go down. Now, you don't have to do it that way. You could, for instance, and this is something that we do with my company. We install a rack of equipment, and we have a limited blended circuit that comes in from the data center. But we also contact these carriers directly. For instance, we'll contact CenturyLink and say, hey, CenturyLink, and it's typically less than what the blended would cost you because data center marks it up. They're also giving you the best of kind of connectivity, which is great. But, you contact one of these guys and say, hey, how about you drop me an individual fiber line and give me a 100 megabit per second connection straight up through you? So you can, in your rack of equipment, bring in via fiber optic cable your own little, drop to one of these carriers. Now, here's the cool thing about that. That may, maybe that carrier says, okay, we'll give you internet access through that link. Sure. But something else that they could do is they could say, hey, we'll give you 100 megabit per second, for instance, like MPLS connection. I know some of you are like, oh, ding, 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 keyword, MPLS. What's that mean? A lot of times when you talk BGP, MPLS goes right along with it, because here's what you can do. You can then, for instance, this is something that we do. We go out to our clients. Let's say we have customer X out here. And we tell them, hey, how about we provide all your IT services? And as a matter of fact, we can be your ISP. So let's just say I've got Jeremy here who's sitting in the data center, and I just told customer X I can be their internet service provider. Literally. So they go, somebody comes up to customer X and says, who do you use for your internet? And they say, we use Jeremy. And they go, no, not who manages it. Who runs your internet? And they go, Jeremy does. And they go, no, people won't get that, of course, if you use a guy's name like me or something like that. But here's what you can do. They can, well, actually, and what we do, we call up CenturyLink for customer X, and we say, hey, CenturyLink, how about you give them a T1 connection at their premise, and you bridge them over to us. Here, let me go green here with a different color. You bridge them straight into us at our data center across that 100 megabit per second MPLS connection that we're paying you for. So they bridge them in right there, and then once the customer is there, again, it's a private line. We are now responsible for giving that customer DHCP addresses on their internet link, and handling their PCs and all that kind of stuff. But we bridge them into the data center, and once they're there, we can flip them out on whatever internet link we want to. I mean, if they're trying to surf the net, we can send them right out that blended connection, that we're getting from the data center. Or maybe we purchase another line straight from Integra or XO or whatever carrier we want, and we say, hey, we want 100 megabit per second internet service. And so we can take that customer, and as they come into us, we flip them out and provide them internet service through Integra or XO or all these other carriers. You get in the kind of, I know this is turning into scribbles at this point, but do you see how this is cool? And this is the new generation. I mean, previous to this, if you wanted to be, carrier worlds, you were, there's before MPLS came out, it was much more difficult to get into this world. Not so much anymore. And also, keep in mind, when you're in the data center and you contact, if you're customer X and you go to Cox and you say, hey, Cox, I want 100 megabit per second internet connection. They go, coffee spewing across the table and be like, woohoo, $50,000. It's just not that much, but it'd be a significant expense to customer X. But when you're in the data center, that's the cloud and all this mystique of the cloud. I'm kind of ripping back the cloud for you a little bit so you see what's behind it. When you're in the data center, if you contact Cox and say, hey, I need a 100 megabit per second internet connection, there's no coffee going across the table, nothing like that, because they're like, yeah, sure. How's $800 a month sound? $900. I'm throwing out relative prices here, but from their perspective, they're like, well, all we need to do is actually just chuck a fiber optic cable at your cage, and that's it. There's no trenching they have to do. They're already there with a gargantuous amount of bandwidth coming in on their fiber optic connection. So they're like, hey, yeah, here, for a few $100 a month, you can have a crazy link, and so welcome to the world of building a transit autonomous system. I wanted to do that to lay that out for you because, again, a lot of times when you read the books, when you look at the technical docs and you start seeing this state-of-the-art data center will provide internet access to customers, it's too mystique. When I say internal or external to the data center connected through various layer 1 providers, it's too much like, oh, okay, well, that's magic. So how do I do BGP routing? And when you get to the real world, knowing BGP routing is just half of it. Knowing the big picture of what you're really doing is the other half. Breathe, Jeremy. Take a sip of coffee. Better. So that's the world that you're looking at when we're saying that. So when we're saying we're building a data center, this might be the Nugget Labs data center. We're going to have carriers in there. We're going to provide internet access to our internal customers, maybe through some of these uplink these carriers who have agreed to install their equipment in our facilities, and external. Maybe we've got customer X. Let's go back to the network diagram now. There we go. I almost lost it for a second. Our network diagram. So this customer could be inside of our data center, or they could be connected via a layer 1 provider. Maybe somebody is managing the fiber optic connection or the T1 conversion or something over MPLS that allows our data center, our ISP, to reach our customer. And nonetheless, we then become their service provider and route them through our uplink ISPs. These are your XO communications, your Cox connections, and all that. So I know I took a long time explaining that, but let me tell you from my perspective. When I learned BGP, it was 8 years ago, and I learned it, and I could make it work, and I could set it up, but I had no idea of the big picture. Like, okay, here's what you really can do with BGP is peer to these ISPs, and this is why you would do that, and all that kind of stuff. So we, at this point, being the data center, are now a transit autonomous system. Let's look at the scenario. And just looking at the time we've taken to understand the service provider, understand the data center, what kind of mindset we're coming at, I'll probably just go through this scenario, just kind of scope it out, and then start the configuration in the next nugget, and they'll be a little more natural that way. So the scenario, I think I made it this far, right? I promise not to not to digress anymore, I think. So your initial build out of the data center will include routing for the internal network via OSPF, uplinks to 2 ISP carriers, and your first offsite customer who will become part of the Nugget Labs Fast Autonomous System. Nugget Lab Fast ISP Autonomous System. Okay, so hey, I got to describe it a little. Okay, so hang with me here. We're going to have in our ISP router, there are 4 routers essentially that are acting as uplinks to customers, uplinks to carriers. They are connected redundantly, meaning if any one router fails, we have redundant paths to reach the other routers. So keeping all that in mind, we're going to roll out OSPF to route internally inside of our network. Not handle any of the external routes, as we discussed in the previous nugget on designing a service provider network. But then we're also going to bring up the connections to our ISP1, ISP2, and our customer. Now, our customer, as most customers are, whether they would be inside of this data center, like I just drew out for you, our purple data center, or whether we've got a physical layer 1 connection, maybe some third-party vendor is providing the underground fiber optic cable or T1 service to that customer. And that's going to bridge them in. Regardless of whether they're in or out of our data center, they'll probably use our autonomous system. Like their part, I know they're kind of falling out of my dotted circle, but GNS3 just won't let me draw a pretty dotted circle like that. So AS500 will also include that customer. They're part of our autonomous system using our subnet, 150.1.0.0/16. That's our Class B block of addresses that have been assigned to us. Maybe that's our independent address block that we own. And we're going to provision some of those for our customer. Remember, we are a service provider, so we'll hand the customer 150.1.1.0, this little Class C block over here, and they'll pay us for that. And we'll have a little public subnet that's connecting on the WAN link. More on that when we get into the configuration. So that's what we're going to be building. To aid in this initial build out, we created the following ordered list of requirements on the following page. Okay, so let's scroll down. Here's our requirements. So to help guide this initial config, here's what we've got. We've got number 1, configure the Nugget Labs Fast ISP routers to use OSPF as an interior gateway protocol. What I mentioned before, we're going to use OSPF to route between all of these. And I know some of you are like, well, wait a second, this is BGP. We shouldn't have to know OSPF. Well, remember, BGP is like an application. It rides on top of the interior gateway protocol, so you have to know something about it, and the faster that interior gateway protocol is, the more reliable BGP will run, because if something fails, you don't want your customers to notice. Well, if you're running BGP everywhere and no interior gateway protocol like OSPF, they will notice because BGP is slow. So we'll look at the details of that when we configure it. We then need a full mesh of iBGP peers between all routers within the Nugget Labs Fast ISP due to BGP split horizon. Now remember, in the last Nugget, I talked about iBGP being a weird protocol in that, let me go back over here, in that if we receive routes from this ISP, it will pass it to its directly connected neighbors, like if I configure these as neighbors, but the rule says these neighbors will never send the route to this neighbor. Remember, the BGP split horizon, not normal split horizon. BGP split horizon says if I receive a route via iBGP, so that'd be right here, iBGP, I will never send it to another iBGP peer. So here's our iBGP. So what we're saying is instead of just forming neighbors between directly connected devices, we want to form neighbors between all of them. So router 1 should be a neighbor, a weird neighbor with router 4 because it's non-directly connected, but that's okay. So when he receives routes from ISP1 on router 1, he'll pass those routes on directly to router 2, router 4, and router 3 through that iBGP relationship. So from there, we've got configure eBGP peers between the uplink ISP1, ISP2, and customer routers. So we're going to be now setting up the eBGP between these guys. And notice I put in here, for additional practice, we're going to be configuring our uplink ISP1, ISP2, and customer routers. Now, that's not normal for the real world. Usually the service writer will say, well, you will pay if we are going to configure anything. But hey, for this lab, let's configure it all, get all the hands-on we can. Then we're going to announce our BGP networks via a variety of methods. We'll use redistribution, we'll use the network command, and we'll use we'll use some different kinds of network commands, and then we'll verify everything. So that's going to be building. That'll be building our initial transit autonomous system. So for now, at this point, I want to draw the line there and say, you know, we've gone over really kind of the big picture of what is this transit service provider network, as well as talking about how we're going to be setting this up, kind of the mindset of approaching this lab. In the next nugget, we'll get into the configuration. So for now, I hope this has been informative for you, and I'd like to thank you for viewing.